In this video we build a small pinball game with Godot using some of the new features in Scalable Vector Shapes 2D. We want to target browsers, so we're using compatibility mode for our new project. Let's use a fresh installation of Scalable Vector Shapes 2D and start out with a flipper for the pinball machine. New in this plugin release is the ability to assign a collision object 2D, which means a static body 2D, an area 2D, an animatable body 2D, etc. In order for the flipper's rotation to interact with the pinball physics later, we will need an animatable body 2D. When coding an animatable body 2D, the engine needs to detect transforms, in our case a rotation, on that node directly. So let's make that node the parent of our drawn shape. Here we paste a script I prepared earlier with some exported properties. Is it flipping up right now, minimum rotation and a maximum rotation, and a base acceleration for the flipping speed. This way we can test it in isolation. The scene has a bare node 2D as a root node. This makes it easy to duplicate a right flipper next to this left flipper by flipping the flipper scene horizontally without changing the rotation script. Here we check that we can still change the shape of a flipper even though we move the nodes around in the scene tree. The next scene is a pinball, for which we use a rigid body 2D and a basic collision shape 2D, nothing fancy. No new features of the plugin are required for this pinball, but let's just use this moment to do a little fake 3D trick by assigning a radial gradient. In order to mimic light shining from somewhere top left, we need the gradient to not rotate. But if we only do that, the ball will just seem to float around. Let's fix that. First, we can just unassign the gradient fill polygon from the Scalable Vector Shape 2D node and make a new fill polygon. This we're giving a noise texture. Next, we make the gradient semi-transparent and implement a script to prevent it from rotating with the rest of the rigid body 2D, which is simply a matter of negating the rotation of the root scene. Noise. Now we'll craft a pinball case to illustrate how you can make cutouts using Ctrl+Shift+Click on a selected Scalable Vector Shape 2D. The cutout is a Scalable Vector Shape 2D itself. With right-click on an edge, we change it into an arc, which we manipulate with the fields in this pop-up. Both the arcs and the cutouts are maintained in list properties of a Scalable Vector Shape 2D, exposed in the inspector. As such, everything can be animated using property tracks and the Batch Insert Keyframes button in the inspector. You can read up on all this in the README manual on GitHub or watch the A to Z explainer video I recorded earlier. The SVG importer has seen gradual improvement. Arcs are now supported, as well as cutouts. Still, parsing errors in certain transforms remain. This will need looking into further. Since cutting holes into polygons is now supported, it also makes sense to add Sculptable Navigation Region 2Ds as a feature. To prevent Scalable Vector Shape 2D from calculating the holes all too often, we now detach the Navigation Region 2D from it. To prove that it works, I outfitted some point light 2Ds with a Navigation Agent 2D to chase the pinball. Runs pretty decent in my Firefox with remote debug on. Don't take my word for it, visit the live demo on itch by following the link in the description. Or check out the code yourself in the examples there of the plugin. To round up, let's mention some other features that are new since I recorded the A to Z explainer. Simple handles for simple shapes with a Convert to Path button. Exporting PNG files with an inspector button. This also works recursively, with multiple Scalable Vector Shape 2D nodes as children. And finally, I added line cap and line joint settings for the strokes. So you can make rounded start caps and end caps, rounded corners, or use beveling. Time for some shoutouts. Special thanks go out to MewPurPur, author of GodSVG and the ARC code I could readily adapt. Mr. KDJI, who made this knife tool, of which I could adapt code for the cutout support, of course. The SVG importer is based on this SVG to Godot script by pixelriot. Of course, I would also like to thank Hedberg Games again, and as our latest contributor, I'd like to thank Thiago for really joining our tiny team of volunteers. Also like to thank HannesParth, link in the description, for being an enthusiastic early adopter and generating cool ideas. Scalable Vector Shapes 2D is available via GitHub and the Godot asset library under the MIT license. You know what that means, I guess? You can't buy me a coffee, but if you ever do make it big thanks to this plugin, well, let's get in touch. All my info is in the description. Keep dreaming.